Since many people are joining right now, uh, we'll wait for 5 more minutes and I will
Sorry,
start the
sir.
session at 16.
Sorry, your voice is not able to get, sir.
Can you hear me now?
Now I can able to get, sir. We
Hello,
shall we shall start the session, sir. Let
can you
them
hear me
join.
now?
Let them join, sir. Okay. A very good evening to one and all present for this third day faculty development program. On and Today is the fifth session. And now I would like to call upon Mr. K. Prathivraj, sir, Assistant Professor from the Department of ECE, to give the brief note about our today's speaker.
Good evening, everyone. Myself, Prithviraj, working as an assistant professor at Christ College of Engineering and Technology. I welcome you all to this Atal-sponsored 6-day online FDP program. It's my privilege to warmly welcome Mr. Akshant Rajkumar Madhur as a speaker for session 5. He is a skilled business analyst with expertise in data analytics, business strategy, and process improvement. And he is having proficiency in many tools such as SQL, Python, Tableau, and Power BI. Mr. Akshan holds a BTech in Automobile Engineering from Manipal Institute of Technology and Advanced Diploma in Automotive Mechatronics from GPP Pune and a Master's in Hybrid Electric Vehicle Design and Simulation from SkillLink. Along with his strong educational foundation, he has applied his knowledge in impactful projects on customer churn analysis, financial forecasting, supply chain optimization, and real-time fraud detection systems. We are honored to have him with us today, and we look forward to gain valuable insights from the topic data collection and processing from EV battery sensors.
Thank you, sir, for your warm introduction. And I hope my voice is audible to everyone.
Yes, audible, sir. The screen is also viewable, sir.
Okay, great. So, good evening, everyone. I am delighted to be here as part of this AICT at Atal FDP. Today's session is about data collection and processing from EV battery sensors, a crucial area for battery safety, efficiency, and future research in EVs. Okay, so the roadmap for today is we will start with the foundation, then move into the technical flow, and finally connect it to real world applications. Let's begin by setting the stage with why EV batteries and their sensors matter so much. So, EVs and the role of their batteries. Batteries are the costliest and most critical component in EVs. To ensure safety and long life, data from sensors must be collected and processed continuously by the BMS. BMS is the battery management system which is being deployed in all the EVs, which is in a short way you can say it's the supercomputer which actually controls the vehicle and each and every aspect of it whenever it is in the running motion in the running condition or is it is stagnant or it is in offline mode. So the importance of sensors in EV batteries is un- unparalleled. It's next to anything else. Without sensors and EV batteries like driving a blindfolded car. Okay. So sensors provide the data backbone to keep the EV safe, efficient and reliable. So, the types of sensors in EV batteries are EV batteries rely on different types of sensors, each with a specific role. Okay, so voltage sensors keep track of each cell's health and prevent overcharging. Current sensors help calculate state of charge SOC or state of charge and protect against unsafe loads. Temperature sensors are crucial for thermal safety. For example, overheating is one of the biggest risks in EV batteries, either while charging or in motion. Suppose, since we live in India, which is subcontinent country, there we expect peak temperatures to ambient temperatures to go around 45 and 46, and we see every year those records being shattered. So temperature sensors are very crucial for thermal safety of EV batteries. Next is the pressure sensors. They detect abnormal swelling which can signal early stage failure. These pressure sensors are also very ac- like high, very much needed in the safety of the vehicle, because these sensors actually prevent from exploding the battery, and they warn the customer or the rider or the driver of the vehicle to get their vehicle checked as soon as possible to the nearest service station. Gas sensors act as a safety net by detecting leakage or dangerous venting. And finally, smart sensors integrated with the CAN bus allow real-time data transfer to the BMS, making advanced diagnostics possible. Together, these six sensor types form the nervous system of the EV battery, ensuring performance, safety, and longevity. Now, the sensor data architecture. Think of this as the nervous system of an EV electric vehicle. Sensors are like nerves of our body. The BMS, the battery management system, is the brain. As I said earlier, it is basically a supercomputer which controls all of the electric vehicle. And cloud ECU is the decision making center. So cloud ECU, what cloud oblique ECU is, what it is? It is electronic uh, compu- computing unit. Okay, so BMS and ECU are interconnected with each other. Okay, so for example, we know that there is a brain. We have a brain, and inside it we have a smaller brain, which is at the back and just above the neck. Okay, so basically, ECU is that decision making center of the BMS. BMS accepts the data, it cleans it, it actuates it, it does everything, it does all the legwork, and ECU is basically deciding what to do next based on the data and the calculations done by the BMS. Next is the data collection process. Like, how is data actually collected in electric vehicles? Previously, we talked about the sensors and the layout and the architecture of the electrical side and electronic side of the EV, and how, why are these sensors required and what are they necessary for. Now will go through the process of data collection. So data collection in EVs happens in two critical stages. First one, we have acquisition and communication. Specialized DAQ systems gather sensor data and protocols like CAN, LIN, or Modbus, ensure efficient, reliable transmission. Among these, CAN bus is by far the most dominant one. Now, why do you think CAN bus has become the most widely adopted protocol in India? Just think about it, and we'll get back to that after. Second comes modes and storage. Depending on the requirement, data can be logged in real time for instant decisions or stored in batches for later analysis. This data is either stored locally on the edge of fast response or uploaded to the cloud for advanced analytics. In fact, over 80% of modern EVs rely on Canvas as their primary backbone for low latency sensor data collection, making it the industry standard. Basically. So, now we have seen the data collection process. What are the challenges which we actually face in the real world scenario in the process of this data collection? Okay. So collecting data from EV batteries may sound very simple, but it's not without challenges. First is data accuracy. Study shows that more than 15% of raw EV sensor readings can be compromised by noise, calibration errors, or packet loss. Without correction, this leads to misleading results and unreliable monitoring. The second is data volume. Interestingly, nearly 70% of all data generated in an electric vehicle originates from its battery sensors. This concentration creates a heavy load on storage, synchronization, and processing systems, making efficient data handling crucial. Together, these two challenges highlight why intelligent data management is essential to unlock the full potential of EV sensor data. Just I hope everybody is following.
Sir, yeah, sir, but little bit volume was needed, sir. The voice is low audible.
Oh, okay. So I'll keep in check of that. So the next stage in our presentation is basically the challenges in data collection. It is a continuation of that. Okay. So collecting data from EV battery sensors appears simple, but obviously it poses significant challenges. Now, so the as we talked previously, noise and calibration issues, right? So over 15% of the readings can be distorted due to interference or improper calibration, leading to poor decisions by the BMS, which is the battery management system, as I said earlier. So data loss during transmission can be critical to data failure to reach the BMS due to packet loss or weak communication, which compromises the overall safety of the vehicle as well as the occupant. Okay? So the next point is sensor synchronization. With numerous sensors in an EV, misalignment in data streams can lead to chaotic interpretations. And lastly, high frequency sampling and data volume. As I said earlier, over 80% of the EV's data originates from sensors, which creates a large volumes, and so it requires efficient storage of this data and accurate processing of it. Because since there are a lot of information which is being flowing through the electric vehicle at any given moment, we don't require each and everything at each and every point of the usage of the vehicle, right? So but you need that data point accurately when it is being required. Okay, so suppose whenever you are running your vehicle, you need to know what is the battery power actually uh, battery power left in the battery pack at the time of pressing the accelerator. Okay, but when you are not accelerating the vehicle, when you are actually braking, or you are stagnant, or whatever, like you are just gliding the vehicle, you are not pressing the using the accelerator. At that specific moment, you don't require that data, that how much battery power is left, but it is essential as soon as you press on the accelerator to gain that access that data, and eventually accurately distribute that power as required to all the full fields. Addressing these challenges transforms raw data into actionable insights, as I explained it just now. So what is the data processing pipeline actually? Like how is the data being processed? This the pipeline terminology is being used when you are to guide how the data is being processed, like what are the steps in this. Like data clean, as you can see in the image here, data cleaning and filtering, feature and extraction modeling, and finally the visualization and insights. This is the basic raw terminology of the data pipeline. Okay, so I'll explain each and every one of them one by one. So the data pipeline has three essential stages. First is cleaning and filtering. So whenever we receive the data from the sensors by the BMS, it will actually go through. First of all, it will go through the cleaning of the data, like whatever the null, void data, and whichever data is as hallucinated data is present in the data set or data line. It will just filter those out, and it will remove those to create an actual usable and necessary data set. And eventually it will go to the next stage of filtering, which we'll go to next. We correct errors and remove noise for reliable inputs. This is basically the gist of data cleaning and filtering. The second feature is data extraction and modeling, where we will translate raw signals into indicators like state of charge, SOH, or RUL, and run predictive algorithms. So wherever we get the clean and filtered data, using that data, each and every predictive algorithm for which is being set for each and everything for charge, battery management, and everything, it will run through those algorithms, and finally visualization and insights, where the processed results will be shown through dashboards and graphs, so engineers can act quickly. So in short, data moves from raw signals to knowledge and actionable insights. So, in what I'm trying to say is the data which we receive as signals, and in terms of numeric data, or in water, in the voltage or current, in whatever form we will receive these signals, we will transform them into actual knowledgeable format, in knowledgeable language, which an engineer or a customer or a user, anybody can understand, using that data and eventually converting it to actionable insights. Next is the feature extraction. Just a second, guys. Yeah. Yes, guys. Sorry for the delay. So the next slide will be feature extraction. So feature extraction is basically about translating that raw data which we discussed in the previous slide into useful health indicators such as SOC, which actually tells us the charge left in the battery on the dashboard or for the user. SOH gives a measure of long-term health. RUL predicts how long the battery can actually last, and fault signals detect anomalies early. Without these features, raw numbers remain actually meaningless. So, as I said earlier, we receive these sensor signals in terms of signals from the different types of sensors. We transform them into numbers, but these numbers won't just make any sense if they are not being processed through an algorithm, right? So these voltage and current sensors is meaningless to either the engineer or even the user. Suppose there's 68% battery charge left in the vehicle, but to the customer, to the driver, we are displaying that this from the voltage sensors or current sensor we are receiving this much current or voltage. That is actually meaningless to him. He won't be able to understand what that means actually. So we use that data and put it into the predictive algorithm. The algorithm will go through the data and it will generate a result which will actually be a data which is actually understandable to the customer. So the next is the ML AI, which is machine learning slash oblique artificial intelligence in battery data processing. So what this slide demonstrates is it's like AI transforms EV batteries into predictive systems. Okay, sorry. So predictive models identify risk before they escalate. Anomaly detection provides early intervention, charging optimization improves battery life, and lightweight onboard AI ensures decisions happen in real time even with limited hardware. So what this does is, so lightweight computing is basically the mruby, which is the basic main topic of this FDP. So what it does is it is an onboard AI, artificial intelligence, which tries to predict an upcoming fault, either a fault or a crash or anything it can predict. For example, currently we have cars running around with ADAS features, which we are seeing for multiple cars, and multiple times we are hearing nowadays that this car has ADAS features. That is basically the detection sensors. They are detection sensors and detection features which actually eliminates the risk of a crash. So, as everybody knows that there are mainly three big players in EVs currently in the world right now. One is Tesla from the US. The second is BYD from China, and the third is our very own homegrown Tata Motors for Tata EVs. So obviously we know that Tesla has taken the lead with its AI-driven battery management systems and remote software upgrades. But BYD focuses on safety by utilizing advanced thermal control systems. Meanwhile, Tata's electric vehicles offer affordable solutions for India, illustrating how each company leverages sensor data to gain a competitive edge. So each and every company which I stated here, they have one or the other edge point over the its competitors. Since Tata is a homegrown company, so it will obviously cheaper than any other car makers. Okay, hello. Yeah. So as everybody knows, Tesla is the one who actually commercialized the EVs to the customer from the theoretical concept to actually making them. So it is in terms of AI capabilities, they have an edge or upper hand. Okay, and they have a large scale of financial injunction behind them. And secondly, BYD, uh, since its inception in China, the actual growth graph of BYD has surpassed Tesla, as everybody knows. Okay, so BYD focus, we know that focuses on advanced thermal systems, because safety is the topmost priority of BYD, and along with that, it it gives a host of features which is actually unmatched by either by Tesla and as well as by Tata EVs. So the next is the application of sensor data. Okay, so whatever data which is being gathered by the sensors, and we know now we know how to process it, and how now we know how it actually uses that data. So now we'll see the applications of those actual data and data figures, and after going through the predictive modeling process algorithms, how we can actually use this data. So the first and most critical area is the safety. So battery failures like thermal runaway or gas leaks can cause fires or explosions. With real-time sensor data, we can detect abnormal temperature spikes, voltage imbalances, or gas emissions early and prevent accidents. So this is basically the safety aspect of the EV vehicle, correct? Yeah. The next is the efficiency. So EV drivers always want longer range and faster charging. This is the biggest talking point whenever an EV comes out. When, like as you know, like 10 years ago, every time a new car is launched, everybody is asking what is the average, what will be the mileage of this car, how efficient it will be. This is the similar case for EVs also. So everybody knows that obviously EV will be an efficient vehicle, but what is the actually the range, and how long do I have to wait to charge the vehicle? Because as you know, for a petrol, diesel, or even a CNG car, the wait time for actually the filling up the tank is hardly more than 5 minutes or 10 minutes, hardly. So everybody wants a faster charging car, because they don't want to spend more time in charging the vehicle, even though they are much more efficient. But as everybody knows, the battery efficiency and everything depends on the terrain and drivability and each and everything, which will discuss in coming slides. So as I was saying, EV drivers always want longer range and faster charging. By analyzing sensor data, we can optimize charging patterns and reduce energy wastage and squeeze maximum performance out of the same battery. So, this statement sounds very good to be true. Okay, so obviously it won't be able to do all of these at 100% capacity, and moreover, to actually implement these strategies, it requires a lot of uh, historical data. So suppose you are buying a new car, you can't expect all these things to happen in a week or in a month. So you have to drive the vehicle to at least a minimum number of kilometer, or for a certain period of time, to actually generate and gather all that data, and then based on your driving capacity and drivability, it can analyze and give the charging patterns, which will eventually reduce energy wastage and squeeze maximum performance. The third is predictive maintenance. Traditionally, vehicles rely on breakdown based maintenance. So, whenever something is broken down, even at that moment only, they will go and change it, or even they will look for it and then fix it. With EVs, sensor data allows us to predict issues before they happen, lowering downtime and cost. So, suppose we are maintaining a vehicle using proper maintenance schedule and proper maintenance schedule and maintaining the car as it is supposed to be, and doing uh, oil changes and everything, so the car will run fine and you won't have any issues. But that is the ideal case scenario which hardly happens in a real world. So what happens is the cars break down either because of lack of oil change or any number of reasons, because of lack of maintenance. So at that moment, what they will have to do, they will have to actually replace the whole part, which could have been easily avoided if they would have maintained the vehicle as it was supposed to be. But in that doesn't happen. So what it will, so in the terms of EVs, this can be avoided by using the sensor data and actually giving a warning to the customer, to the driver, that this is supposed to be maintained and this is supposed to undergo a maintenance schedule, maintenance checkup by this time. And if it doesn't happen, there's an issue of there might be a breakdown, and which will lead to higher costs. So finally, research and innovation. Engineers and scientists use sensor datasets to test new battery chemistries, improve cooling systems, and design better energy storage. The EV industry moves forward because of the knowledge gained from these data driven experiments. So, sensor data doesn't just live in a lab or BMS, it directly shapes the safety, performance, and future of electric vehicles. Yeah. So, what do you think the future lies for the EVs? Okay. So, looking ahead, the role of EV battery sensors will only grow. The first major trend in the integration of IoT and AI. In the future, EVs won't just collect their own data; they will share it with fleets, researchers, and manufacturers. This creates a continuous learning ecosystem where every car gets smarter with time. The second direction is blockchain for EV security. Blockchain for data security. Since EV data can be sensitive, related to performance, ownership, or even warranty claims, blockchain ensures it is tamper proof and trustworthy. Third is lightweight computing, something especially relevant to our FDP's focus on embedding. The idea is to embed intelligence directly in the car's hardware, even with limited computing power. This allows the BMS to make real time decisions without always relying on the cloud. Finally, hybrid cloud edge analytics is the way forward. Critical time sensitive operations like preventing a thermal runaway must be handled on the edge, right inside the vehicle. Large scale analytics like understanding fleet wide degradation trends will happen in the cloud. In short, the future of EV batteries is intelligent, distributed, and secure, combining multiple technologies to make EVs safer, smarter, and more efficient. So, to conclude, as we wrap up, let's bring everything together. We started by understanding how EV sensors are the backbone of EV batteries, providing the vital signals that keep vehicles safe and reliable. Without sensors, there is no way to monitor or manage a modern EV battery. Thank you, everyone. Now I'll begin taking the questions if you have any.
Participants, if any of you is having any doubt regarding You can raise your questions. Participants, you can raise your questions. Sir, any doubts? So thank you, sir. Really, your session was informative. With short note, you are given a brief information, which might be a, idea for others to go into it. Uh, Participants, any doubts? If so, kindly unmute your device and you can raise your questions.
Thank you, guys. This has been a great opportunity, and I hope everybody has learned a little about it, if not everything. And
Not little, sir, much more.
and actually,
But
I would
within this short sperm, you have given more ideas and information, sir. Really, more and more informative.
sure. Thank you for your positive
Thank you for
feedback.
having you, sir. Okay, sir. Thank you.
Thank you.
Participants, kindly wait in the session. The next speaker is going to join within a few minutes.
Okay. Thank you, everyone. I'll take your leave, and I hope everybody follows EVs and take the positives out of everything. Even though there are a lot of negatives which is being floating around in the social media and everywhere, but let's look at the positives and move forward. All the best, everyone. Thank you.
Thank you, sir. Thank you.
Hello.
Participants, the next session speaker will be joining by 7 p.m. So you can have a break and join by sharply 7 p.m. participant. So make your presence sharply by 7 p.m. Thank you. Welcome, ma'am. Participants, kindly make your present active. The next session speaker has been joined. Ma'am, shall we start the session?
Hello.
Yeah, ma'am.
Thank you, sir. Thank you. Hope I'm
Okay.
audible.
Yeah, audible, ma'am. Good evening.
Yeah.
Now we are in the sixth session of the sixth third day, and now I would like to call upon Mr. Prathivraj sir from EC Department, Christ College of Engineering and Technology, to give a brief note about this session speaker. Sir, welcome you, sir.
Okay. Good evening, everyone. It's my pleasure to introduce our Session 6 speaker, Ms. Sharmila. She earned her bachelor degree in Electronics and Communication Engineering from Satyabama Institute of Science and Technology. She is currently leveraging her technical acumen as a software developer at NatWest, where she contributes to building robust, scalable, and secure applications. With over 4 years of hands on experience in working with microcontrollers such as Arduino and ESP module, she has developed expertise in prototyping and implementing real world IoT solutions. Her technical proficiency also extends to VLSI design and electronic circuits, enabling her to bridge the gap between hardware and software. She is deeply passionate about emerging technologies and their transformative potential. With her unique blend of skills in electronics, IoT, and software development, we are certain that her insights will be highly valuable and inspiring all of us. Let us welcome Ms. Sharmila. Welcome you, ma'am.
Thank you. Thank you so much, sir. So, good evening, you all, dear professors. Hope I'm audible. Shall we start?
Yeah, thank you, sir. Ma'am, you can take over the session, ma'am.
Yeah.
Yeah,
Thank
eagerly
you.
waiting for your informative session.
Thank you. Thank you. Let me just share my screen. Some of you can notify if my voice goes down because I have a very feeble network here. So, if my network goes down or if I'm not audible, just please indicate me.
Sure,
Okay.
ma'am, sure.
Yeah. So let me just share my screen. Hope the screen is visible.
Yeah, screen is visible, ma'am.
Yes. So today's discussion will be on data handling in MRuby for battery health management, basically. So in the previous session, you would have heard about MRuby and frameworks, etc. So now let's see how this MRuby is being used in the electrical and electronic sector for battery health management and performance, and how it is being used to handle the data efficiently. Okay, let's go. Oops, I think my system's battery is low, I guess. I need to take a pass here. Okay, it's just ideal scenario that I have simulated here. You just see, it is just a seminar, and we all on a sudden we just had enter into a nervous mode. Even I, if this is happening to me in such an important seminar or somewhere else, then suddenly we would have entered into a panic and nervous mode, right? So this is where the data handling plays an important role, especially in the battery health management system. So the device that I'm using here is just a simple personal computer, but you just think of the wide range of electronic devices in the crucial platforms like healthcare, mass transportation, airlines, in the space technology field. So everywhere, wherever we use the electronic and electrical devices, battery plays the efficient role and the important role, right? So if we uh, look into the industry, the mass industry, where they use power grids, solar grids, so the battery health management is really important, and they have to gather a mass data to monitor the performance and to predict how the battery health goes and how it is performing. So that is important in order to maintain the efficiency of the whole system and to make it less error prone, right? Let's just go into it. So, when we speak about battery management system, it is the essential part of any uh, electronic or the mechanical system that relies on the electricity. So, so in order to make the entire system continuously working and reliable, a huge amount of data to predict the you know to predict the errors or to predict the malfunctions that is going to happen in the battery system earlier is essential to avoid the system goes into failure. So here we can say this BMS is like a brain of the battery pack. So that ensures safety, long life, efficiency, continuous working of a system that relies on a battery, right? Also, there are few core functions of PMS. So, what a battery management system does is the continuous monitoring and protection of the entire system. Uh, Load balancing. Okay, load balancing between all the devices. It ensures that the power supply, the voltage is being transferred to all the devices in a uh, equalized load. And estimation, yeah, and so estimation is the part where we are going to concentrate much on. Okay, also we have some few state of estimations which we'll be discussing in depth. And finally, communication. So there should be a centralized system, or there should be a centralized cloud to store all these data that is coming from a battery informating system, right? These estimations, monitoring parameters, and all the data, such as the power ratings and the power supply that is being sent to each and every devices, has to be saved somewhere, and it has to be communicated effectively. And all these comes under the battery management system. And there will be a centralized repository which will be collecting logs from all devices, and it will be capturing all the scenarios that is happening within the ecosystem for a single device. And industries will be uh, you know uh, summating all these logs and will be using for the further analysis and to improve the efficiency of the further build system also. uh, Here, the data analysis plays a central role in the BMS and also in the performance optimization, because batteries are, as already said, they are the complex electrochemical systems. Also, their performance changes dynamically based on the usage. They are not standard systems. We are just incorporating some electrochemical systems inside a battery, right? It will degrade over usage over time. Even if you don't use it for several years or months, it will start degrading. So there are several factors affecting a battery. So monitoring it under every circumstance is very important, right? Uh, so now let's come to the estimation part. Uh, we have to estimate the performance of or the data that is collected from the system. And we have three types of estimations here. One is a state of charge, the state of health, and the state of life estimation, or you could say the state of power estimation. So, what is meant by state of charge? It's nothing but the data analysis. This state of charge data analysis helps us to estimate how much energy is left in the battery more precisely. Okay, it just gives us the information of the overall power left rather than telling this is the voltage rating of the battery. So this estimation helps us to ensure that we are using the leftover power, leftover energy efficiently. Okay, so this state of charge helps us to estimate that. And the second one is the state of health. So it defines how much capacity the battery has. So, and you know, we already said the battery degrades over time. So this state of health monitors how much power the battery has over time. You know, that it is holding over time than compared to its earlier stages. That means when it is constructed newly, right? Yeah, obviously, we having during initial times the battery might have withheld more power ratings than it is now. So this degradation calculation helps us to determine how long the battery will perform efficiently when kept in the particular system. So this also helps us to replace the batteries or change the systems whenever needed, and the state of life. So uh, this estimation helps us to measure the amount of current the battery safely conduct for the nearby devices within the given time. So this estimation helps us to calculate the current that the battery can provide. So these are the main estimation we are considering in the battery management system. Uh, so so why are we doing it? As already said, by doing these analysis, by doing these estimation, we will be able to analyze the voltage, current, the temperature patterns. Yeah. Uh, I forgot to mention, temperature is one of the important factors in the battery health. So monitoring the temperature and logging it is one of the crucial step in the battery health performance analysis. So we cannot skip it. Uh, and so these analysis helps us to predict the abnormalities in the earlier steps itself. Mm. Also, we have many MI and AI models that uh, flags the anomalies before itself, so that we can avoid some sudden failures or some sudden explosion of batteries and all. So nowadays we can see in the news. Uh, so the electric vehicles batteries are getting exploded when they are getting exposed to some high heat or high voltage, etc. So having these data incorporated in the entire electronic system will give alert if some certain parameter exceeds. Let's say if the temperature is exceeding some degree Celsius, or if the voltage rating is exceeding to some ohm, then you can simulate some alerts to notify the user that the battery is overheated or the battery is gonna fail soon. So based on the alerts, we can save the device by cutting the power supply that is given by the battery to the device. So, so the data analysis comes into this area, right? So it helps us. It is not only helps us to build a efficient battery management system or efficient batteries, but also it helps us to prevent accidents caused by battery systems or the faults caused by battery systems, right? Also, these data trends helps us to optimize charging and discharging profiles. Okay, by analyzing these data, we can just determine, okay, at when we need to charge, at what level of battery power needs to be charged, and when the battery needs to be disconnected. So these can be identified by analysis, by the detailed analysis of the data trends that we have. Also, there are various algorithms, as I said, we have that suggest us the adaptive charging strategies. So these AI and ML model needs a large amount of data for it to give the accurate output. Also, in the design of BMS, we have simple cell balancing to ensure the overall performance. This this cell balancing ensures the uniform degradation and better efficiency. Uh, Also, this helps us to this helps us to forecast the remaining useful life of the battery and helps us in the predictive maintenance. So, uh, so to keep it in shorter, data analysis is nothing but is the brain of the modern battery health management. As I said, it ensures the safety while pushing for like innovations in electric vehicles, medical healthcare innovations, renewable energy products. This plays a crucial role. So now looking into it, many standard programming languages and frameworks such as Python or language, Java, is for embedded systems, especially, right? We have standard libraries, we have advanced models in Python, right? So why we are preferring mruby over these things? Let's see that. Uh, so mruby is basically a very lightweight framework of the Ruby programming languages, right? And we see this is not entirely into the industrial ecosystem right now, but the industries, the small startups that relying on this embedded or the electronic systems are slowly adapting this mruby due to its uh, lightweight implementation. Uh, so So, to say exclusively, mruby is designed for limited memory and processing power devices. So, Python, R, they are exclusively used for the enterprise and huge applications. But for standalone devices, for standalone simple systems, simple frameworks like mruby would be efficient because its processing power and its processing time will be low compared to our standard frameworks. That's what we need, right? We need the instant alert when something goes wrong. In such case, mruby helps us because of its uh, limited processing power and time efficient processing. So it can calculate the things quickly and it can just forecast us that the system is going to perform in such a way. So yeah, uh, and to come into data analysis, so the data science field, let's see how mruby is contributing. We have certain gems of the mruby, such as daru and numo. The daru gem, it is a gem. Gem is nothing but they are kind of frameworks and libraries within the uh, Ruby ecosystem. They are inbuilt libraries. Uh, these libraries are called as gem in Ruby environment. So the Doru gem provides a data frame structure, similar to one that is found in Python's pandas library, right? So s- pandas and numpys. They are the libraries existing in Python, and they are exclusively used for the data analysis and data visualization, right? Uh, so similarly, in mruby, we have the Daru gem that is used for organizing and manipulating the data. It's exclusively the tabular data. And we have this Numogen that offers efficient numeric ways for high performance scientific computing. So if it is a simple system, we can just do simple mathematical analysis. But for complex systems, we need a strong scientific computing, right? That is where our Numo hides. Uh, Also, we have the statistics and machine learning models, libraries like StatSample. Right now, I don't have any, some live interactive demo to show, as these libraries are, we have to pay some cost to get some libraries. So as of now, I'm just mentioning the libraries, but in a detail I can share it as a link to you to go through about the gems, about the libraries and their implementation. Right now, due to some constraint in my office system, I cannot lively show a demo. So I'm just mentioning the library names here. Like the libraries like StatStamp will provide a range of statistical functions, while there are some other gems like Decision Tree, Ruby Spark, and they enable machine learning tasks, which we can use for our data analysis. And we have other gems for visualizing the data. So we gathered the data, we have to visualize it in the user with some good user experience to the user, to the end user who are using it. Right? So not all the users can understand the mathematical terms or the numerical values. So here the data visualization is important again. And there are some gems like Rough and Ruby Plot, where it will allow the developers to create some various charts, graph, and visually appealing uh, ecosystems for the end users to see how the system is performing in terms of battery resistance. Also, interoperability is one of the advantages for this mruby framework. Uh, this Ruby can also interface with some popular data science libraries from other languages as well. Like we have the PyCall gem in this mruby framework, which allows to call some Python libraries in some scenarios, like mruby and matplotlib for plotting the graphs and for detailed analysis. So via this PyCall gem, we can call those Python libraries directly for our analysis in the mruby environment. So also we have some client called reserve client in the mruby environment, which provides us uh, a connection to the statistical programming languages like R language. So while mruby is not dominant as Python, but we can use this and we can implement this at some areas to some extent, particularly within web applications to provide you know uh, user interactive ecosystems and user interactive web dashboards. Is that not fully visible? Okay, sorry, this pop is hiding, I didn't note it, sorry for that. Hope it is fully visible now. Yeah. So, and I would like to go through some existing gems in Mruby. There are some gems. First one is mruby.io. This is a gem which handles the input and output operations of files, the connection sockets, etc. So this is one of the gems to handle the input and output output interactions between the systems. And the other library is mruby dir, which is the directory handling. We can handle our project directories, our system directories using this gem. And we have the other thing called socket, mruby socket. This especially supports the networking, so it handles the network protocol related stuffs. So this mruby socket library handles this. It is especially for tcp udb communications. And for data handling and data pricing, when we come to data analysis, data cleaning, this data handling plays an important role in order to make our data efficiently, right? For that we have inbuilt frameworks, inbuilt gems like json. uh, we all know, right, json. uh, and we can use this gem for the json format encoding and decoding. And we have other thing called mruby msg pack. It is specifically for the binary serialization. So, and we have also another gem, YAML. You all know, right, the YAML file format. So this mruby YAML gem is used for the YAML parsing. So it is able to decode the YAML files. It is able to read the YAML file, and it can work with this gem, mruby YAML gem. So why are we speaking about JSON YAML structures here? So in some of the systems, the BMS would have to send some structured data. So for such structured data environment, we are using these gems like YAML and JSON gems to make the data structured and serialized. Uh, and we have other math and algorithm related gems that can be used to reuse the environment within the mruby framework. We have mruby math gem, which does basic math operations like basic math calculations, sine, cos, tan, square root, lambda functions, etc. So whenever these calculations needed, we can just pull in this gem and we can use that in our environment. And we have CMath gem, which is exclusively for complex math operations. When we deal with calculus or integral part of the mathematics, we use the CMath gem of MOB. And also we might need to handle with logarithmic functions, regex functions, right, in the data. So for that we have a separate gem called mruby uh, on ig. uh, I think, yeah, that's regex gem. So that is specifically used for the uh, regular expression and other logarithmic operations in the mruby environment. So, as far we have seen about the math calculations and the data format, right? Uh, the data structure gems that we are using, and now how the device will communicate. So, how we can implement that using mruby. So, but for that also we have certain mruby gems here. So we have communication and protocol related gems in the mruby framework. They're all inbuilt and we can use it. So one of the gems is serial port, which is used for serial communication with the controllers existing within the system. And the second one is the MQTT gem we have, that is exclusively for MQTT protocol, which we extensively use in IoT systems, right? So we have that gem in MRuby, and these gems are very lightweight and they can be used in small systems that will operate in some constrained environments. And we have HTTP gem also to uh, help for the HTTP protocol and HTTP communication within the system and as well as the cloud, with the cloud. So it provides the client server support for the system. This gem when we implement NVOP. Uh, so when we see in the BMS models in electrical vehicles and the stationary energy storage can that will be sending real-time data to the IoT dashboards to display the efficiency of the system, right? There we would be using this MQTT and HTTP protocols, right? There we use this MRuby gems to implement those protocols. Uh, Also, we have other utility gems like MRuby process that processes handling of the system, and we have environment uh, gem that is called MRuby ENV that ensures us that we are accessing to the environment variables in the right. Also, we have some other gem called MRuby time that is used to uh, time and date management. So when we speak about data and log taking, date and time is important. At what time and at what circumstance the voltage, the current, the temperature is being recorded is important. So we can use this MRuby time gem for the time and data management, right? Yeah. So using this gem we will be able to log the specific time where some of the exceptions are occurring in our electrical system. It's like if the battery is overheating, we can see in the log like the battery is overheated at some x time. So to log those times we will require this mruby time gem. So um, so let's see how the industries are adapting to this mruby in recent times. So it is mainly using this MRuby framework for edge analytics. We have already seen about the MRuby math and the MRuby JSON gems that allows the BMS battery management system to process raw sensor data like voltage, current, power rating, the temperature, into some usable insights. So using these gems, we can manipulate the raw data that we are getting from the sensors and the system. Also, using the HTTP, MQTT, and the other protocols, other TCP, and other communication protocols, we would be making the system, the entire electrical or electronic system, to communicate with the higher level systems. Like we can make it to communicate with cloud or some other systems using this MRuby gems, using this MRuby communication protocol gems. And like yeah, and for safety and diagnosis, so we can also implement some rules and algorithm using these mruby gems, and also we can trigger some scenarios using these gems, uh, and we have flexibility and efficiency when we use this mruby, because as we already discussed, it is a very lightweight framework. Unlike ruby is kind of full work, but when we just dive into the mruby, it is a lightweight framework. It can run on microcontrollers inside the electric vehicles or some electronic systems where we'll be having only the limited resources. uh, so instead of hard coding everything in C or C++, we can extend this software mruby frameworks and this mruby gems. Uh, we can use this modularly actually instead of hard coding everything. Instead of parsing line by line of code, we can use these gems simply and we can move. do this. So, in short, to say, this Ruby gems provide or they act as the building blocks for this construction of the entire system. Not only the BMS, I'm just saying wherever we use the embedded systems, we can just pull in these Ruby gems to construct it efficiently, and also for data hand because we have a number of little libraries, a packet of libraries within this framework which are ready to use. So, in industries, which means in electric vehicle industries or in the biomedical industries, biomedical instrumentation industries, or in the renewable energy system, we can use this MRUB framework. Uh, so where we have the constrained environment. So this is all about that, and I would like to show you a MATLAB page. So this provides you the high-level overview of the battery development system workflow. So it will help you to see how the BMS is being developed and how they are collecting the data. Actually, it is done in MATLAB, but it can give you an idea, right? So may I know how frequently you're using MATLAB in your projects? May I please know the scope of MATLAB there in your respective departments? Professors? Hello? Okay, I assume that MATLAB is being used for some certain projects. But using MATLAB, using the existing algorithms and existing libraries within the MATLAB, we can use that to construct the entire battery system. So this page speaks about that. So how we could develop some algorithm for a battery management system for a particular device or particular environment. Also, how we can integrate those components to run some simulations. It also provides the testing platform and the deploying platform. So, using the testing platform, we can test how efficiently our system works. Also, we have some inbuilt AI and ML models to predict and to analyze the data within the MATLAB system. So you can go through this when you're free, and you also start practicing in this MATLAB environment. It also gives the fantastic, you know, the workflows. Also, it supports some inbuilt AI ML models, and it supports inbuilt graphical representations, inbuilt data analysis. So you can go through this. I'll share this with the coordinator. Maybe this, and we were been speaking about the gems, right? I'll just give the necessary links to explore those gems and the implementation, right? So, yeah, that is all. We are towards the end of the session, and this is the overall high-level overview of how MOB can be implemented in the data analysis of the systems. So to say more, the industries are a bit reluctant to adapt it due to its lightweight approach. In some cases, it might be efficient, but if we speak about the mass data collection, still it lags in specific areas. So this framework is enabled to process a huge amount of data at a single time. So this sets a drawback for it. That's why it is still in the developing phase. But for some simple systems, we can use it. And the platform is now open for questions.
Participants, if you have any questions, you can raise on. with a limited time period, we have got a more information about the mruby. That is the language standards which supports. If you have any doubts, you can raise your questions. Ma'am, the session was really informative, but due to lack of network, we could not able to get you more.
Okay, sorry for
I think so.
that.
You're having another more session.
Yes, yes, that, and I'm happy that that is falling on a weekend, so I can spend more time
Oh,
professionally.
sure, sure, ma'am.
Yeah.
Participant, do you have any questions? Okay, so you just gather and you can ask the questions when ma'am was another session. No one? Okay, ma'am. Thank you for your informative session.
Thank you so much. Thank you so much for the
Thank
opportunity.
you.
Let's meet on
Sure,
Saturday.
ma'am. Sure, ma'am. We are waiting for your another session.
Yeah, thank you.
Participant kindly fill the feedback link which is posted on the chat box.